Subscribe Technity and press the bell icon so that you never miss updates from Technity. Hello guys, welcome to Technity. We all have seen computers, laptops in this generation, and today we shall discuss about quantum computers. What are they? How they are different from conventional computers and microprocessors and much more. Stay with me till the end. So let's begin. So guys, basically a computer consists of desktop, keyboard, mouse and also CPU, which is the main unit of the computer. So to explain the concept of quantum computing, I am focusing on central processing unit and microprocessor. CPU is the main part of computer which is capable of fetching the instructions and giving the output according to the input sent. And also microprocessor is the main unit of CPU which is capable of performing arithmetic and logical operations and giving the output according to input given to it. So let me explain you about the microprocessor. So microprocessor basically consists of registers. So basically registers are the memory storage devices. Like we have SD card, secure digital card and hard disk for storing data. So basically registers are the responsible for storing data. So going in depth, registers are made up of flip-flops. So flip-flops are the digital logic devices which is capable of storing single bit of data. For example, a flip-flop can store single bit of data. So we have different kinds of flip-flops like JK flip-flop, D flip-flop, and further if we go into depth, each flip-flop is made up of logical gates. So what are logical gates? Logical gates are basically electronic devices which can perform logical operations like logical multiplication, logical addition, and logical inverting. So basically logical gates perform operations on binary bits. So let me explain you the concept of bits. So bits mean basically zeros and ones, but in electrical sense 0 stands for 0 volt and 1 stands for 5 volt. So it needs not to be exactly 0 and 5 volt, for but this concept we can take it as 0 and 5 volt. So for example, if I take a AND gate which perform basic multiplication and if I give 0 and 5 volt as the input for the AND gate, I'll get 0 as the output. So it basically means 0 into 5 gives 0. And further going into depth, a gate is made up of transistors. So what are transistors? Transistors are basically switches which allows or blocks the flow of current through it. So basically transistor consists of three parts: emitter, base, collector. So depending upon the current in the base region, it allows or blocks the flow of current. So the charge carriers which are present in transistor are responsible for the transistor, which makes a transistor as an extraordinary device. There are millions of transistors inside microprocessor and the size of transistor is getting reduced day by day as the speed of microprocessor is getting increased day by day. But here the main problem is we know that the size of transistor is around 14 nanometers, but if the size goes on decreasing further and once if the size of transistor becomes equal to the size of an atom, which may be approximately equal to size of an atom, then it will be difficult for a transistor to block the flow of electron, that is to block the flow of current. This is according to quantum physics. So the solution to this problem is quantum computers. So basically quantum computers uses a specialized bits called quantum bits or qubits. Like we have binary bits which are 0 or 1, but in quantum bits these are capable of storing either 0 or 1 or 0 and 1 and infinite number of combinations. Yeah, it may be confusing, but we can notice that light can also behave as a particle as well as wave nature at the same time. So in the same way, the qubits are capable of storing multiple combinations or infinite combinations of data at a time and fetching as well as decoding them at the same time. So instead of fetching information in parallel or series, the quantum computers fetch all the information at the same time. And it is estimated that a quantum computer can process the instructions parallelly, which is million times faster than the ordinary computers. So, in order to achieve quantum computing, we have to satisfy certain conditions, such as we have to have magnetic field and also cool computing. So, what is the concept of cool computing? Basically, we have silicon, which is atomically heavier materials. So, in order to achieve quantum computing, we have to make a lower temperature conditions. The lower temperature stands for a temperature around absolute zero. So we have to satisfy this all condition to obtain quantum computing phenomena. So this was all about today's session. Thank you for watching. Like, share, subscribe Technity for further technical videos. Thank you.